Hello, we are Team Soccer Stars and we've made a goal-scoring robot. All three of us play soccer, so we thought this would be a very fun project. This is a video of what inspired us to make this robot.
That's 1-0 to the Autobots.
This is our simulation setup. We have the UR3 robot with the gripper attached to one side of the end effector, as well as a Hokuyo sensor on the other side. We also have a sphere representing the soccer ball. This is our soccer goal. We included 2 goalies to make scoring a bit harder.
So the most interesting part of our project was having the LiDAR sensor detect the goalies and also the shift in goalie positions if we wanted to. As you can see in this video, the initial cluster of goalies are marked by the circular set of points on the right side of the graph, and as the goalies shift from left to right, the cluster of points which are more circular also shift with the graph.
One of the obstacles that we encountered was using inverse kinematics in Coppelia Sim. When we tried using the built-in IK solver, the robot would move to a position in unpredictable configurations, which meant we may accidentally hit the soccer ball without meaning to. We solved this by using our code from Lab 5 and then using those thetas as a guess for the modern robotics IK solver method, which resulted in predictable and accurate configurations. We use trajectory planning by creating parametric equations for a circle that hits the ball perfectly. We then applied a rotation matrix based on sensor measurements to hit the ball at the right angle. This is an example of a robot moving in a perfect circle using inverse kinematics and our parametric equations.
To find the angle to kick the soccer ball, we first need to find the goalie's location. Since we do not know if the goalie will be accompanied by a defender, we used hierarchical clustering. This distinguishes the clusters from each other if needed. In the left case, there's only one goalie, but in the right case, there's a goalie and a defender with him, and the clusters are shown by the circles on the LiDAR sensor graph next to it. We then find the average location of each cluster and make sure we do not shoot at it. One problem we had was when the goalie and the defender were right next to each other. In this case, the clustering algorithm grouped them into the same cluster. We allowed this to pass as one goalie and continued. The angle chosen would be the further corner of the goal, so this method of merging the goalie and the defender together worked.
We had to use noise filtering for the LiDAR sensor since the noise was in form of collinear points. So in order to do that, we essentially had data where there were a lot of points that were formed lines, and we essentially found the slope between each pair of points and then checked to see if there were 3 or more points that had the same slope, which contributed to the same line. And if they were, like in this case, it's approximately the same line, we eliminated those points. For the angle prediction, we used the dimensionality of the edge of the goalpost, and if we had a goalie or 2 lined up like this, we found the distances between the gaps. And we took the largest distance, which in this case would probably be this one, and we found the midpoint, y value. And since we had a predetermined x value from the robot to the edge of the goalpost, we made a simple triangle like so, with our y and our x here, and calculated the angle using simple trigonometry.
First, the robot takes a snapshot of sensor data to detect the locations of the goalkeepers. Then, it calculates a good angle to shoot the ball and executes the planned trajectory. We can also move the keepers, and the robot will dynamically calculate the best location to shoot the ball in order to score a goal.